Hi all, in this video we will talk about path determination. In last video, I explained to you how a routing protocol works at its base. And this video will be about how a routing protocol determines which path is good for it. And few other issues that needs to be addressed and how different routing protocols has different ways of solving those issues, right? Now, if you look at this topology, at first glance, the information sharing procedure that I explained to you in the previous video seems very simple. Now, look at router A. Router A checks that, okay, 2.0/24, 1.0/24, 3.0/24 is directly connected to it. What it will do is it will update that information to its routing table first. And it will, beside that, mention that these are directly connected routes. Now, whenever a routing information is added to a routing table, besides that, it has to write how did it obtain that information. Okay, in this case it is directly connected route, so it will feature that thing. It can be a static route that is added by the user or admin. It could be a dynamically learned route, right? So it has to mention beside it. Now router A places that information into its routing table, and after that creates an information packet and shares that with its connected routers, in this case router B and C. Now router A transmits those copies as the information packets, right? Then this procedure seems very simple and fine, right? But still, we know that routing protocols are much more complicated than this. And now we will understand what are the complications. And in the upcoming videos, we will slowly, gradually understand what are the problems and we will try to solve them. And we will see that how a routing protocol is designed. Now, the first question is, what should router A do with the updates that it has got from router B and router C? Right. First thing it will do is that it will look at the routes and it will update it to its routing table. Then what should it do? Should it drop that packet, delete that packet, or should it pass that information after analyzing to other routers as well? Right. What should it do? And if router A, you know, gets network 4.0, let's say this 4.0 is connected to router B. Then router B will share that information with router C and router A as well. But if you look carefully, let's say it is time 0, t equals to 0, and at this point of time, no routes are exchanged. At t1, at t equals to t1, router B will share that route with A and C, right? Now A will get this information and update it to its routing table. But at t equals to t2, after some time, C will share that information about 4.0/24 with router A, right? Now router A has some ambiguity here. Which route should it choose? This route or this route, right? There are two routes. So this question says that if router A hears about 4.0 from both B and C, which router should be used to reach that network? Are they both valid? And if they are both valid, then which is the most optimal one? Okay. And second thing is, if 4.0/24 is shared by router B to router C, then what it will do? Let me clear the screen first. At t equals to 0, router B will share that with router C, and router C will share that with router A. It is now T1. Now router A will tell to router B that I have found a route to 4.0/24 and it is 2 hops away from me, right? And see what's the confusion here, that router B knows that 4.0/24 is directly connected to me. Now router A is telling me that 4.0/24 is 2 hops away. This is a great confusion, right? And every routing protocol should have a mechanism to prevent this problem. The question says, what mechanism will be used to ensure that all routers receive all routing information while preventing update packets from circulating endlessly through the network? It will be exchanged to A, then A will send it to B, then B will send it to C, and this is how it will circulate around the network endlessly, indefinitely, right? These questions are very simple, right? Very simple questions, but they give you an indication that there are some complex issues hidden, and we have to understand that how every routing protocol, you know, takes into account these questions and solve these questions in different way. Every protocol has their way of solving these issues. Let's say how to prevent loops, how to exchange packets, which path is good, which is more optimal, right? So every routing protocol, let's say EIGRP or maybe OSPF, they have defined their algorithm, and we will be learning about them in future videos. And in the next video, we will talk about matrix. You must have heard about this term, but in next video, I'll explain to you, and we'll gradually get into more depth in this routing, dynamic routing protocol series. And that was it for this video. Thank you so much. If you have any doubt, you can write down in the comment section.